Section 11.4, the relationship between temperature and volume. This is also known as Charles's Law. And again, I don't care if you know that it's Charles's Law or not. Some people will, but I don't. All right, so the volume of a gas is directly related to the temperature in Kelvin. Very important. Okay, anytime you see capital T, that means temperature in Kelvin. But gases, Kelvin, apparently Kelvin, gases always use Kelvin. Okay, and anytime, Kelvin apparently, anytime you're talking about energy, you're also using Kelvin. See if I can spell it correctly this time. Okay, so Kelvin, 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 pretty important here. So it's a direct relationship, right? And this is how they came up with the idea of absolute zero. So here we're going to be changing the volume, or actually let's change the temperature. We're going to be changing the temperature. We're going to see how the volume of that gas changes. They started plotting that. Okay, so this is 0 volume, this is 0 Kelvin, so this is in Kelvin, this is in liters. They started plotting that relationship, and what they found was that if they extrapolate that relationship back, so they got to the data right there, if they extrapolate it back, they see that at 0 Kelvin, the gas will occupy 0 liters of space. Now that can't be true, because all matter occupies space. So that's why 0 Kelvin is, what they think is the coldest temperature. All right. So the relationship is right here. My one suggestion that I have for you, V1 T1 equals V2 T2, and students make this mistake every year. If you are solving for temperature, get it out of the bottom. Okay? Students always make the mistake of leaving temperature in the bottom and algebraically solving the equation wrong. All right? So first thing, get that temperature out of the bottom, use your algebra skills that you have, and then you can also go and take a look at the video problems. I don't have them listed here. They'll be listed later on.